All right, so now we're going to take a look at Rule 8-104, maximum circuit loading. And we're going to apply that, the rules in here, to this example we did for voltage drop on the hot tub. So the requirements that you have to do every time is be able to select the conductor, apply the termination temperature rule to it. Is it a continuous load, etc. And there's lots of stuff you need to do. So it's not like just learning one thing at a time. When you become a journeyman there, when you're a qualified person, you've got to do a string of rules here. So we're going to put all these together. All right, so let's run through the rule in this first video, and then we'll tackle the example and the rule that pertains to this installation. 8-104, maximum circuit loading, see Appendix B. Let's go look at that note right away. So once again, students, when it says see Appendix B, go there and read it. It's there for your help. Let's take a look. It says here, 8-104 and 62114. This note applies to both rules. 62114 is the overcurrent device for heating circuits. And it says here, when an overcurrent device is located in an assembly, such as a fuse switch or a panel board, the assembly is required to be marked for continuous operation of its overcurrent devices in accordance with the requirements of CSA C22.2 number 4 and CSA 22.2 number 29. These are Part 2 standards, so the people that build the fuse switches, the manufacturers that build the fuse switches, that build the panel boards, are required to mark their equipment, whether it is suitable for continuous use at either 100% operation or 80% operation. The next note says, fuse switches and circuit breakers not marked as suitable for continuous operation at either 80% or 100% of the rating of their overcurrent devices are considered to be suitable for continuous operation at 80%. So you have to understand that, let's take a look here. We have a fuse disconnect switch and we have a panel board. How this 80% and 100% rated equipment works as it pertains to both. So in the fuse switch, I'll open the switch here, and inside the switch, on the marking that is required to be on the switch, for example, says here, lugs are suitable for 75 degrees C, copper or aluminum. So that's marked at 75 degrees. So when we come to our example here, 4-006, when equipment is marked with a termination temperature, we are limited to the 75 degree column on the ampacity conductors. First thing you would have to do, then when I keep reading on the switch here, on the marking, it says right here, the starting current of motors of more than standard horsepower rating may require the use of fuses with appropriate time delay characteristics. Continuous load current not to exceed 80% of the rating of the fuses employed in other than motor circuits. So this switch is an 80% rated switch. What that means is I can only load the switch up to 80% of its rating of the fuse that's installed in it when it is a continuous load. All right? On a panel board, here we have a circuit breaker and a panel board. The circuit breaker has to be rated for 100% operation, and so does the enclosure. So what is the difference between a 100% rated enclosure and an 80% rated closure? It's really quite simple. You get more surface area for contact on the fuse clips, etc., and the enclosure is bigger and it's ventilated. It has the ability to dissipate the heat. On the panel board, the enclosure would be wired, more space and more venting. You cannot put a 100% rated circuit breaker in an enclosure that's not marked as suitable for 100% operated equipment. They work together. Breaker and enclosure. The switch itself is marked as continuous 80% or 100. It's not the fuse that's the problem. It's the clips, etc. All right? The fuse is rated, if it's a 100 amp fuse, it's rated for 100 amps. I put it into a 100% rated switch, I can load it up to 100%. I put it into an 80% rated enclosure, I can only load it up to 80%. All right? So that stuff has to be marked on the equipment. They do not mark the 80% rated circuit breakers. They're just simply not marked. The switches, it's marked right on the nameplate. The panel board enclosure itself would be marked, and the 100% rated breakers are marked. The standard circuit breakers that you buy and you install in single-family dwellings, they're not marked. So you can only load them to 80% of their rating. So let's carry on with the rule itself. So this note, you guys, you absolutely have, as a journeyman electrician, continuous loading, it's critical. Let's go back to the rule. It says here, the ampere rating of a consumer service feeder or branch circuit shall be the ampere rating of the overcurrent device protecting the circuit or the ampacity of conductors, whichever is less. So if I have a 200 amp breaker and a 190 amp wire, it's a 190 amp service. If I have a 200 amp breaker and 225 amp wire, it's a 200 amp service. So it's just a statement. Subrule 2, the calculated load in a circuit shall not exceed the ampere rating of the circuit. So here's the rating of our circuit, 31.25 amps. I can't put a 30 amp breaker on it. Another statement. Then subrule 3, the calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that in normal operation it will not persist for a total of more than 1 hour in any 2 hour period if the load does not exceed 225 amps, or B, a total of more than 3 hours in any 6 hour period if the load exceeds 225 amps. That statement right there, 3, where it says the calculated load in a consumer service feeder or branch circuit shall be considered a continuous load unless it can be shown that a normal operation will not persist for 4, and then you have those A and B. So every load is continuous unless you can prove otherwise. It gets restrictive on your wiring, etc. Subrule 4 says a load of cyclic or intermittent nature shall be classified as continuous unless it meets the requirements of subrule 3. Subrule 4, a prime example of that is your domestic hot water tank within the service of a single-family dwelling. Then we have subrules 5 and 6. All right, those ones here are the next lesson that we're going to do. All right, so we have to pick which one, subrule 5 or 6, is going to apply to our installation here where we did the voltage drop calculation. We're going to go with an 80% rated circuit breaker, and we are going to apply the rule to the wiring method, and we're going to string all these rules together to make it all happen. All right, so we'll see you in the next one.